Welcome to our presentation about the preparation of black mass samples using ColdBlock. I'm Craig West, the CEO of ColdBlock Technologies, and I'm pleased to be sharing some of these findings with you today. Before we start, just a couple things to mention about how this session will run. First, it is being recorded, so there's no need to take detailed notes as we go through here. You will receive access to this recording afterwards. If you've got any questions during the presentation, please feel free to type them into the chat function. We're going to take as many questions as we can. We'll do our best to answer everything at the end of the session. And then finally, just a reminder to stay muted to ensure the best experience for everyone during the presentation here. So let's get into it. ColdBlock technology is a revolutionary sample digestion technology that is using shortwave infrared heating and a cooling zone. Our technology has been sold in many different sectors around the world, and some of the world's largest commercial labs are now using ColdBlock sample digestion technology. What our technology provides is a much faster sample digestion process. We're doing in minutes what traditional technologies are taking hours to do. We're doing it with a technology that emphasizes and improves safety within your lab. It adds efficiency and increases your throughput. And all of this while yielding the same accurate, repeatable results that you're used to receiving. In this webinar, we're going to talk about some of the factors and forces that are causing a demand for black mass testing to increase. We'll talk about some of the challenges that labs are facing, some of the things that we're hearing about from our commercial lab partners. And we'll talk a little bit about the solution that we've come up with here at ColdBlock. So black mass, as we all know, is the product of the battery recycling process. End-of-life lithium-ion batteries are shredded and separated into various streams. And one of those streams is black mass. It's a mixture of the metal oxides and compounds that we're trying to recover and recycle and use in future lithium-ion batteries. In order for that recycling process to work and work efficiently, we need to have a good testing process, something that can identify and quantify the metal content before the processing begins. So black mass is critical to determine which metals can be recovered and which quantity of metals we should expect to recover. Lithium, cobalt, nickel, manganese, all of these can be recovered and analyzed and quantified using ColdBlock's digestion technology and subsequent analysis. We've seen real growth in the EV market over the last couple of decades. Demand for EVs is continuing to grow. What this has pushed is a real demand growth for the raw materials that are used in battery production: lithium, cobalt, nickel, manganese. That demand for those raw materials is starting to outpace the amount that is being produced by mining operations around the world. And what is now being required and what is becoming more important is this recycling industry, is an emerging industry that will take end-of-life lithium-ion batteries, recycle them, and recover those same elements to supplement what we're getting from the mining operations. So that elemental analysis is critical. It's critical for these recycling operations to control and quantify and understand how much of each of these elements they should be recovering. What the issue is that the industry currently doesn't have a testing method that can keep up with those processes. We don't have an elemental analysis process that will allow these recycling companies to test and understand metal content at a rate that will keep up with the recycling processes. So here's some pictures of black mass. Why is this a complex sample type to try and analyze? Both of the pictures you can see on the right are black mass, samples that we've received from some of our industry partners. You can see the top one, very large chunks of metal and other materials still present. And in the bottom one, a very nicely refined, processed, and prepared sample type. What we're hearing from our lab partners is that they are receiving a very wide range of these different types and different levels of preparedness of black mass. So we need to come up with a method that can handle that wide range of sample type, can handle the wide range and distribution of metals. The other challenge that we're facing is there's a very wide range in sample reactivity as well. So that lack of homogeneity, it makes this a very complex sample type to process. So this is what we set out to do with our R&D lab that we have here within ColdBlock, set out on a goal to try and create a sample preparation method for black mass that could handle the range in sample preparedness, the range in sample sizes, the range in particle sizes and reactivity, and to do it with a method that was going to be fast, efficient, and accurate. And that's what we accomplished. The team first developed a near total digestion method showing that a sample of black mass could be nearly fully digested into solution. And then we developed a workhorse, something that could be used day to day to day that will deliver the same level of accuracy, but with a process that was much shorter in timetable. So let's talk about the first method, the near total sample digestion method. This method, you can see the results on the right, nice, clear, clean solution. All of the solids have been taken into solution. This digestion took us 50 minutes. We did it on a 0.2 gram sample size, which as we've just discussed is not ideal, but it does help demonstrate and does provide a bit of a foundation as a method that can be used to give a near total digestion and assured results. The challenge with this method, though, is that it does take a lot of steps. You're using a sulfuric acid and a nitrating solution. So as a result, it does require a certain amount of care and attention to execute safely. This is going to be a good method where if you need to run a check and have a confirmed data on 1 in 20 samples to ensure that you're getting the recoveries that you need. The data that we got on this method was excellent. You can see on the far right some of the recoveries that we were getting for the elements in question. We've shown results here from 2 batches that we've run. We're continuing to add to our library using this near total digestion method. The other thing I would highlight is the percent RSDs there. The repeatability is excellent with this method. And again, the results that we're showing is this digestion method compared with the current industry standard, which is fusion. So now let's take a look at our leach method. This one, again, was developed to be a much faster digestion process that could be done on a much larger sample size. And you can see here, the method we've developed is completed in just 25 minutes, and it will handle sample sizes of up to 20 grams. Yes, the solution on the right is not nearly as pretty and clean as we're used to seeing at ColdBlock. The carbon or graphite from the batteries is still not been fully dissolved. It's still there in solution. But again, what we're trying to develop is a method that will give us good, accurate results for the elements in question and do it quickly and with the right sample size. So let's take a look at some of the data. Again, we've compared some of these versus the fusion method and some of them compared with our near total digestion method. And we were excited to see that the recoveries that we were getting for the elements of interest was excellent. Excellent recoveries with this. So in other words, there were negligible amounts of elements in question that were tied up in the carbon at all. We're getting excellent recoveries here. And again, the RSDs are also excellent. So let's take a quick look at a video now, show you ColdBlock in action, and then we'll move on to questions and answers afterwards.
In this video, we'll demonstrate the digestion of black mass samples using ColdBlock digestion technology. 20 grams of the black mass sample is weighed and added to the tubes. Large size tubes are used for this digestion to accommodate the larger sample size required for black mass. 45 milliliters of nitric acid is then added, 5 milliliters at a time, in order to mitigate the reactivity of the sample. As you can see, just adding the acid to the sample creates a reaction. We recommend letting it sit for 5 minutes between steps. 10 milliliters of 5% anti-foaming solution may be used. 15 milliliters of hydrochloric acid is slowly added, 3 milliliters at a time. ColdBlock is set at 60% power, and the digestion is completed in just 25 minutes, 2 10-minute intervals with a 5-minute pause in between. When the focused shortwave infrared light heats the sample particles, the digestion really begins to accelerate. At the end of the digestion, the solution appears dark and murky. That's simply the nature of this sample type. Once it's cooled, it's ready for analysis. We recommend bulking to 100 milliliters using 2% nitric acid solution. The digestion is completed in just 25 minutes. Results include excellent recovery of cobalt, lithium, manganese, and nickel with a high degree of accuracy when compared with known values. For more information, including full application notes, visit us at coldblock.ca.
Thank you. And I hope that video showed a little bit about how easy it is to use ColdBlock, how simple the process is in transferring samples and completing the digestion using our touch screen. We're continuing to work with industry partners on even more black mass samples and continue to receive samples from industry. We're building out our library. There are many types of batteries out there and many different preparations of black mass. And to date, we haven't found anything that can't work with these methods that we've presented here today. We're hearing from our partners again that sample size matters, that some of the black mass preparations do require 10 to 20 gram sample sizes in order to get accurate results. And we're pleased to have developed a method that can handle this sample size. With this and the results that we're receiving and the simplicity of ColdBlock, we're anticipating that our technology will become the industry standard for preparation of black mass. We're going to step now into some of the Q&A. Happy to answer any of your questions. I see some of them already on the chat, and we'll get into some of those. But if there are any other following questions, or if you're watching a recording, please feel free to reach out to us at info@coldblock.ca. We have many simple, easy ways to get ColdBlock into your lab to try. We have a new 90-day trial that will allow you to bring a unit in, set it up, work with our lab team to develop a method, and see how well ColdBlock can work for you. Let us know if you've got any interest. And now let's get into some of the Q&A.
Why don't we jump into the questions here? One of the first questions we have, how does ColdBlock handle different battery chemistries and cathode materials? If we take a look at some of the samples we've received from industry, we've got a handful of different nickel manganese cobalt samples, NMC, LCO battery type we've received, LMO, lithium manganese oxide. All of these sample types that we've received do work very well using ColdBlock methods. We've seen a range of like we've discussed, range of preparedness. But all of those sample types work very well with the methods that we've just presented and see very strong recoveries of nickel, cobalt, lithium, and manganese. Nickel, cobalt, aluminum battery types, we received some of those as well. For the near total digestion method, we do get excellent recoveries of all key elements there. We are working right now to optimize that method for aluminum with the leach method. Aluminum does require a little bit more aggressive oxidizing environment, so we are optimizing that method, the leach method for that specific battery type. And then, of course, you've got lithium iron phosphate, which is a difficult method, a difficult sample as well, and we're optimizing our method for that as well. But we've seen a very wide range of different battery chemistries, and again, like as we've said, the bulk of them work quite well with ColdBlock. What kind of anti-foaming agent do we use is the next question. We used for our method, we used Triton X100 as an anti-foaming agent. This is a non-ionic surfactant that suppresses the foaming. It's good in sort of carbon-rich or reactive sample types. But there's lots of other anti-foaming agents that are out there that can be used. We haven't tested all of them, but that's the one that we have used for this method, and it worked quite well. The next question, what kind of instrument did we use for our analysis? For all of our processes, we used our Agilent 5100 ICP-OES. In our unit, we have a vertical dual view configuration, which works well for high matrix samples like black mass. Our setup allows us to collect both axial and radial views of the plasma, helps optimize the sensitivity while maintaining robustness. So that's our setup. I mean, there's lots of other brands out there, PerkinElmer, Thermo. They all have vertical torch configurations, especially in some of their new equipment that's out there and the high medium end. But anything could be used there. But again, we're using an OES for our analysis. The next question here. Have you benchmarked both methods against CRMs or current industry methods? Yes, we have. We have run this against both the fusion method that's out there, benchmarked against samples that we've received from a lab, and as well, there is a CRM that's out there that we utilize as well, and we've benchmarked everything there to confirm the results and to confirm the recoveries that we were receiving. So yes, absolutely benchmarked. What steps are applied between the leaching step and analysis? Is there any filtering? Give me just a second. Yes. We do recommend filtering on the leaching one. You can use a filter, a step to remove any residual solids, and then we dilute the solution appropriately before we're introducing it to the ICP. So that's our step in between there, between leaching and analysis. I hope that answers the question. Okay, sorry, there's a few more questions coming in here on the chat. One of them here, what are the method detection limits? So we are, still obviously compiling all of the analytical data that we've received, and looking at all the elemental recoveries, the USDs, and method detection limits are being calculated. I think rather than go through all of those technical details during this webinar, we do have a comprehensive package of data that we can send to all participants here that show those calculations and show the details on our analysis to get to our method to calculate the detection limits that we're getting with our methods. Sorry, just have a second for the next question. The next question is, how complete is the leach? Excellent question. How complete is the method? Obviously it is a leach. It isn't a total digestion method, and that's by design. What we're trying to do here with this method was to mimic industry standard screening procedures, much like you would use an aqua regia digest for early exploration stage samples or trade evaluation. This is a very clearly a leach. We do get excellent recoveries of all of the key elements in question here. Obviously, we're not fully dissolving refractory materials like you would find in the LFP battery types, but it does give a very excellent recoveries and snapshot of the recoverable metals that are in there. And as well with the leach, and given the methods that we're using, we're obviously able to then do up to that 20-gram sample size. We've verified our method using 20-gram sample size. There's obviously room for optimization there as well. Next question. The next question here is, what is the digestion temperature? Excellent question. We actually get this question not just for black mass, but for pretty much every sample type that we get. ColdBlock does not run off of a temperature setting. It runs off of a power setting. And that's quite simply because of how we're heating the sample. Unlike traditional methods like a hot block where you're heating your test tube, which is then heating up the acid and it's coming up to boiling temperature, or even microwave where you're just basically heating up the acid itself up to its boiling temperature. With ColdBlock, we're delivering the energy right through to the sample. So the sample itself is superheating. It is heating well above the boiling temperature of the acid. That's why the acid itself is boiling. There's not an accurate temperature reading that can be given there, given how we're heating the sample. All of our processes and methods, as you'll find on our webpage, are all utilizing a power setting, and you can set the ColdBlock power setting from 0 to 100. And so you'll find all of those methods on our webpage. All right, next question. We have a question about lead acid battery chemistry. A great question. We have not been looking at lead acid batteries. For black mass, the testing that we have done has been on black mass, which is recycled lithium-ion batteries. So we haven't tested lead acid chemistries and checked there. Something we would absolutely be willing to have a further conversation about. Follow up with us, please, on info@coldblock.ca, and we'll see what we can do to get some of that work done as well. Great question. Next question is on scalability of the ColdBlock system. Yes, you're correct. There is a continuing growth in EV demand and therefore continuing growth in analysis of black mass. Our system just in general is quite scalable. You can connect multiple digesters up to the same controller. We have some customers that are using 2 and 3 and 4 digesters connected to the same controller. You can run everything at the same time. So the scalability, and for black mass, as we mentioned at the beginning, we're using our large digester, which will do 12 samples at a time. So that can be scaled then up to 24, 36, 48 samples at a time if you're looking at larger batches, if you're looking at that kind of scalability. Great question. All right, next question. Have you, a good question here. Have you analyzed other elements apart from these 4? And if so, what are the recoveries? Yes, we've analyzed a wide range of other elements. We can provide all of those details if you like. And we can provide more detail there. Certainly, we tried to summarize the data that we had into the tables, as we do with many of our application notes. But there is a larger amount of data behind that. I would say the only other element that's kind of interest that we have been doing some focus on is aluminum. For that, there's a battery type that contains aluminum. We get excellent recoveries like we said, in the near full digestion method. In the leach method, we're not getting all of the aluminum in, but we're optimizing that again. And again, that may just require an additional oxidizing step to be able to get those aluminum recoveries up. But we'll provide all of those details upon request. Shoot us an email or info@coldblock.ca. Does the anti-foaming agent allow you to use a smaller tube size? In some other applications for ColdBlock, yes, it does. In this case, no, because again, if you're going to be using a 5, 10, or 15 or 20 gram sample size, you need to use the larger diameter test tube in order to utilize that size. Our smaller tubes, the mediums, are typically used for something less than 2 gram sample size, and our small size digester is, again, primarily used in the food and agriculture space for people who are using a 1/10 of a gram or 1/4 gram sample size. So the foaming agent, what it does is allows us to typically apply a higher power setting while still controlling the amount of reactivity in the sample. So it's really just to keep the speed up. Good question. Next question. Do you operate this in a you say wash down hood? I think you mean like a vent hood. We do. This unit is meant to be installed in a standard laboratory vent hood. We have some of the specs are on our webpage over the recommended extraction rate and airflow. But yes, as much as ColdBlock has the cooling zone on top, and we do see a lot of reflux, a lot of the acid vapors are recycled back into the test tube. There is still some venting of acid, absolutely. So it needs to be operated within a hood. Next question. Can you digest petalite, and what acids would you use? Great question. I don't think we have any app notes on our webpage at the moment for petalite. It's on our list of things to do. Some of the other spodumene concentrates like pegmatite, yes, that's on there, but petalite, I don't think we've run that yet. Again, we always love suggestions like that from customers, and those kinds of inquiries gives us something else to work on. But if you take a look at the ColdBlock webpage under resources, there is a list of CRMs and application notes for them. So you can see what we have done. There's others that haven't been posted yet. We're trying to post more every week. Something gets added on there, but I appreciate the suggestion. Okay. Here's a question asking about the near total method and the size that we used, the 0.2 grams. Excellent question. You're right. And as I said earlier, it isn't an adequate size for a near total digestion. We know some labs that were doing their total digestions at about a gram. So we are working to optimize the near total method to see what we can do to optimize size there. We don't mean for it to be the day-to-day, everyday method. We wanted to kind of start by proving ColdBlock could be used to do a full digestion, a near total digestion, and we demonstrated that. The leach method, so we use that as our benchmark, but then the leach method that we've developed, we think that'll end up being the industry standard. That'll be what will be your go-to because it can still give you the recoveries that you're looking for the elements in question, but I still do it at the larger sample size. Good question, though. Good question here on will this be suitable for volatile elements like mercury? Yes, we get this question again, not just for black mass presentations like this, but for many different sample types across many different industries. ColdBlock works very well for volatiles. The cooling zone that we have, the cooling block that does condense a fair amount of the vapor, and the combination of that and the fact that our digestions are very rapid, they're quick. There's not a lot of time to lose volatile elements. Our recoveries, and you'll see this in the application notes on our webpage, our recoveries of volatile elements like mercury or arsenic are very good. A great question, but you'll see some of the data there, and you'll see some of that in the other data that we can provide as well. Okay. Listen, there's a handful more questions that I see here. We're coming up to our time limit, and as we said earlier, we will do what we can to answer all of these questions. We'll make sure that any participants on this call or any requests that come afterwards for participants, we'll provide you with sort of written answers for all these, a little bit more fulsome than I've been able to provide here on this call. Thank you for your participation and your interest today. We're excited by our findings at ColdBlock and by the methods we've been able to develop. We've had some excellent feedback from industry and some excellent interest in our technology. It is starting to roll out at a number of labs for this expressed use, and we think we'll continue to see more of that. But if you've got any follow-up questions, please reach out to us, info@coldblock.ca. Happy to answer all of your questions, and we'll be following up, like we said, with a copy of this recording, with the presentation deck, and with some of this Q&A written up. But thank you very much for your time today. Appreciate it.